Hi everyone, welcome to another EAStalk webinar. Today with us is Børge Søraas. He will do a presentation on aquaculture without borders, an aquaponics journey in Norway. Børge has experience from the edge of the fish tank to the boardroom and everything in between. After completing his education at NTNU Trondheim, he has been operation manager at smolt facilities, built fry facilities for cod, built and operated a sea-based facility for cod, and worked with the breeding of marine species in many Asian countries, including the constructions of barramundi hatcheries in Thailand. He has also been a project manager in Indonesia and Cuba. He was general manager of one of Norway's leading technology suppliers for land-based farming and sat on a large number of boards. For the last 2 years, he has been developing commercial aquaponics and circular solutions for aquaculture. My name is Anna Viskovic and I will moderate this webinar. The webinar will last for approximately 30 minutes, and after that we have 15 minutes for the Q&A. So make sure, in case you have any questions for Børge, to write it down on the Q&A, and I will make sure that we ask Børge the question after the presentation. I would like to thank you again, Børge, for joining us today and for accepting the invitation to present your company and to present the work you do. Feel free to start with your presentation.
Thank you for that, Anna, and thank you for the invitation to come here and talk a little bit about sustainable aquaculture, circular aquaculture, and focusing on aquaponics. So I will try to share some experience and some opinions and foresight according to this. A little bit about the company I work in. It's a company named EcuNor Aqua. It's a small competence and consulting company in aquaculture projects. We are doing consultancy, advice to external projects and companies, but also using a lot of time for an internal project that is the focus here today, and that is to develop industrial aquaponic. And the target here now is from next year to establish a commercial aquaponic in Trøndelag, mid-Norway, and we call that project EcuNor Aquaponics. I said my name is Børge, and you told already background from university in Trondheim as a biologist. I've been a fish breeder for 10 years, both in Norway and other countries. Been a partner in aquaculture technology company, doing a lot of recirculation projects, both Scandinavia, Europe, and Asia, etc. and Latin America as well. So that is the background, and the last 3 years has been in own company in EcuNor Aqua with the target of more circular solutions for aquaculture. I guess it's a big range here of knowledge about aquaponics from 1 to 10, but I choose here to take it a little bit maybe basic, and later on, if someone wants to talk more details about different things, please contact me later on. You will see my contact at the end of the presentation. But to make the start, aquaponics, as maybe most know, it's a combination then of aquaculture and hydroponics. And hydroponics is then plant production in water. So on the right side, we see what we call the aquaponic circle, where you start with the fish, you have nutrition from the fish, consumption of nutrition from the vegetables, and the water back. I will come back to this. So According to traditional aquaculture, and if we have the focus on environmental impact, what is the status about that today? Yes, we have inputs into an aquaculture system with maybe eggs or fingerlings and water. We have input of fish feed, where you have the protein and the minerals, etc. So the output is, of course, then fish. And then we have a loss. We have a loss of quite big amounts of nutrition and waste, the brown going down in the picture, and also quite a lot amount of water going out of the system as a waste. If we look into hydroponics, we will see a similar situation according to the environmental impact focus. Also here we have some inputs, and that will be traditionally some fertilizers and nutrients. It will be quite a lot of water. And again, the output will be plants and some bio-waste, and as a loss or waste or pollution, we have quite big amounts of fertilizer and water as well, as we did see in the aquaculture. So what is the solution then? And one of the solutions that is in our mind, aquaponics. And that is to put these two productions into the same system. And if you are looking at the picture on the upper right, we will see the principle about the aquaponics. We start with the tank with the fish, and from there the water goes to a sedimentation tank or a filtration tank where you take out the particles. Then the clean but nutritious water will go to the next step, that is the hydroponics. Here it's illustrated by a deep water bed where the plants are floating on styrofoam, where the roots are submerged in the water and absorbing the nutrients there. This makes the water cleaner, and then this cleaner water goes back to the fish again. So this is a simplified version of aquaponics. And the benefits of this is that we are reusing, of course, the nutrients, we are reusing the water, so we are lifting it quite a high step up on the sustainable and organic ladder. And another thing that is what we love about this system is that it's a very honest production. You cannot cheat, for example, with chemicals or pesticides or antibiotics, because the fish and plants, they are dependent on each other. If you choose to have pesticides in your plant production, that will not be okay because of the fish, and opposite, antibiotics into the fish, it will be not acceptable according to the plants, etc. So it's very honest. And yeah. So how to put this into more aquaculture projects setting? What is the opportunities about this? We see now in Norway, in Sweden, in Belgium, France, rest of the world, we see a large number of big farms being built and also planning to build. For example, typically we see 5,000, 7,000, 10,000 ton farms that is rising up, and most of them are using a recirculation system. So how can this be utilized into the topic of today? If we go back a few years a little bit, we can see what was the traditional fish farming system, and that was the flow through. So the upper part of this picture shows, okay, you have the fish farm in the middle with a large amount of water going into the farm, and then flow through and large amount of water going out of the farm. It's difficult to do anything good about this big outlets from these kind of farms. But since what should we say, the 2000s, the recirculation aquaculture systems came into more professional stages, and became actually the preferred technology for the land-based farms. And the benefit of this was, of course, that it was technology developed to have internal cleaning inside the farm. So that led to small intake of water and then small outlet of water, much more handleable according to do something both with the intake and outlet. So in the internal cleaning system, we can see down in the picture that is typically consists of mechanical filter to take out the particles. We have a biological filter to do something about the ammonia. We have a degasser that is taking out the carbon dioxide, adding some oxygen, and then we can reuse. So if you look a little bit more into just that cleaning process, is that, as I said, we will get sludge out from the mechanical. We have some small water, nutritious water coming out from biofilter. We have carbon dioxide coming out from the degasser. In a normal aquaculture setting, this is considered as waste and pollution. But as we already have been talking about, this is actually the inputs we need for plant or photosynthesis production. So if you go back again a little bit to the principle about aquaponics, this is the principle, and it's often referred to as the one loop system. And that is, you have the fish with the outlet water going directly to the plants. The plants is using some nutrients, and a little bit cleaner water is then going back to the fish. And as a principle, it's working, but it's maybe not the optimum solution for a commercial and industrial production, because in a single loop there are some limitations. For example, we have different pH optimum demands between the fish and the plants. The fish typically will maybe have 7 to 7.5 as optimum pH. The plants will typically have 5.5 to 6 in pH, and so we will then in a single loop be some place in between and not finding the optimum for either of the productions. Also, there will be some different farms that will have, for example, a cold water fish there. It will be different temperature optimum. For example, a trout or Arctic char maybe wants to have 12 degrees, 13 degrees, while the lettuce or the tomato or the cucumber want to have 22, 23 degrees. So then it will make a complicated system for automation to be able to handle these optimums. So what is the solution then to optimize this? And then we come to what is so-called multi-loop systems or decoupled systems. This is described in a PhD degree from Wageningen in Netherlands some years ago by Simon Godek. The principles, as we can see in front of us here, you have the fish going to, as a single loop, the fish water, the fish outlet water is going to the plants. And but on the way back, the fish has to go through some kind of distillation or filter or something that is making a brine that will go back to the fish, and then the clean water will go back. No, sorry, the brine and the concentrate will go back to the plants, while the clean water from the filter or from the distillator will go back to the fish. In addition, you have a loop with the sludge line, as you can see down there. It's going to be stored, and it can be stored for, we call it demineralization. It can be aerobic or anaerobic. But the point is to bleed out all the nutrients that still is in the sludge particles, because it's a lot of nutrients there, but we need some more time and handling to be able to extract that out and make like a brine or fertilizer that we can additionally give to the plants. So this is what we believe is the industrial solution for this kind of aquaponic principle. And what kind of environmental impact will that give? When we put this together, we see we have the same inputs and outputs as the two other slides we did see. In addition, we have some demineralized sludge, maybe some methane if we have an anaerobic digestion. And the big difference here is, of course, the loss. We don't lose any nutrients, and we almost don't lose any water. So that is taking it at a very high level of sustainability and resource reuse. According to what is happening in Norway, Europe, etc., it's now a trend, a very good trend, that is biopark is on the way to be established many places. And this is an example of some plans in Sweden of a biopark. I will not go into details, but what we see here is a number of activities that is linked together. So all of these numbers you see here, that is a fish farm, that is a greenhouse production, it's a biogas production, biofertilizer plant, water infrastructure for agriculture, etc., etc. All of these are connected to each other, so everyone has, no one has waste. All the normal waste from these activities is the resources for the neighbor. And this is a thinking that is more and more coming now in all European countries. We can see it started a little bit in Norway, the thinking about it, quite a lot in Sweden, and also in Europe, as we know. And this is just a example diagram of something, a biopark like this, where we can see the different arrows that represents the outputs and the waste. It's not going out of the diagram, we can see it's going to each other. And of course, we are talking about also green energy in things like this. It could be, of course, also wind energy. It could be also energy from pyrolysis. That could be a good fit. Sludge and waste is going to biogas. That could be also be compost. So it's no limits, but just an example of how the different activities is utilizing each other in their production setting. And why is this interesting for aquaculture? Why is this kind of solution interesting? And of course, it is many good reasons for that. Of course, everyone wants to be cleaner and greener, so that is a motivation by itself. But also the authorities is helping us a little bit about having a motivation, because the regulations on emissions and environmental footprint, it will be stricter and stricter in future. And we see already it's quite strict, and especially in the European Union legislations, it's already very strict, and probably it will be even more strict in the future. So these kind of solutions can help with that. And according to the benefits that we earlier been talking about, of course, reduced footprint by reuse of water, nutrients, and also what I feel is fantastic about this is that when you are putting this plant production in combination with fish production, you can actually, it's enough nutrients in the outlet water to produce 8 times the fish amount. So in literature, you can see probably some place between 5 and 10. According to our experience, we find out 8 times is the number. So that means when you're producing 1 kilo of fish, then you get actually 8 kilos of plants on the same nutrients, and that's nice. A little bit back to our own projects in EcuNor Aqua, that we are calling EcuNor Aquaponics, and that is to be a part of developing industrial aquaponics. So we have a three-step plan about this, and we have now for 3 years been doing number 1 here, and that is a test facility for establishing the basic technology and protocols, and also been testing this multi-loop technology and document that. The second step is to then next year to make a commercial pilot to make it up to a commercial stage, and then the third stage to make it really industrial. So our conclusions as per today is that the first 2.5 years has been giving us the answers we wanted. So now we have the confidence to go to the next step and starting to build the commercial pilot next year. The pictures that you see to the right here, it's from Superior Fresh, and that is not just by coincidence it's taken. We are looking quite a lot toward that direction because Superior Fresh is an aquaponic startup in Wisconsin in the USA. And in our opinion, that is probably one of the very best startups we have seen of commercial and industrial aquaponics. So it's very interesting to follow their development, and it has been a little bit inspiration for us to look that direction and see what happens. So we are sharing a lot for what happens over there. Have some few pictures from the test facility during the last 2 years. We have been testing many things about methods and also about products. Here we can see some microgreens and herbs. It's in a vertical ebb and flow system using the fish water. Here's a picture from one of the water beds, deep water culture or production of lettuce, and the quality is premium, really nice quality from this. I've been testing tomatoes, cucumbers, herbs, etc. So just to see and verify the protocols that we have been using. And this is a drawing of our plans for next year, the commercial pilot, to take it one step closer to the industrial solution. As you see, our solution is not industrial building with vertical. It is a greenhouse solution for the plant production. That is our choice of scaling up. So what is else happening in Norway regarding aquaponics? We can see in the news that there are a few large salmon companies that now, one actually already started a little bit, and 2 others, they want to grow vegetables from the outlet of the fish water using the principle from aquaponics. That is good. Their motivation is, I guess, and obvious, to be greener, more sustainable, etc. So, but it also some challenges about this that I'll come back to. In addition, there's a handful smaller upstarts like niche, more maybe urban project that is also starting up. So, it's we cannot say that we have a industry yet in Norway, but we can see the start of it. And back to what I said about the challenges about the big players producing vegetables, and that the question is then, can aquaponics handle all the nutrient flow from aquaculture? And since I'm asking that question, I can say the answer of that is no. If you take example of a Norwegian fish farm or a Swedish farm or whatever, if you have a farm that is typically 7,000, 10,000 or 5,000, that is the size that we see that all the new farms are coming. In a freshwater farm of 7,000, that will actually give the nutritional basis for production of more than 50,000 tons of vegetables. And that gives us something to think about according to the market, because in Norway we consume per year lettuce, for example, 21,000 tons, cucumber 29,000 tons, etc. So here's an example. One farm alone can produce all the lettuce and cucumber that we need in Norway, just one farm. So that can be a challenge if everyone wants to produce cucumbers or lettuce or tomatoes. And then, of course, another question is also, according to many farms that is not freshwater farms, can aquaponic principle also be used in marine systems? And the short question, the short question is no, not at least if you are going to produce vegetables. So ordinary hydroponic plant production must have fresh water, and then someone are looking into if it's possible with some reverse osmosis and stuff, but the problem is that then you also take out the other nutrients, so it's difficult to see how marine land-based system can be used for traditional vegetable production, at least in our opinion. But we believe that there are so much other things that you also can produce than vegetables, and that is, of course, algae. Algae is a very good candidate for marine farms to use the aquaponic principle, and then also then produce a marine algae or algae that can handle brackish water. Another option is also produce a biomass that you can then go more into a value chain for further products that I will come back to. Let's talk just then a little bit about the option about microalgae. I've been borrowing this slide here from Kari Atramedal. She works in Nofitech. It's a technology company in Trondheim that is working with fish farm technology. So she has been kind to borrow this to me. She has been working a little bit around this. But microalgae is a candidate to be utilized in using the aquaponic principle, and then we are of course talking about the multi-loop system where you have these advanced filters, etc., where you're harvesting the nutrients from the fish farm. I will not go into all the details, but it's an option. It of course has some challenges, and it has not been done much yet in commercial scale. But there has been doing some very good work about this in, for example, Sweden. Maybe several of the participants in the webinar today know about this. And in South Sweden, there is a startup from Swedish algae factory that is connected to a salmon production farm, and this is then brackish or marine water. And they are producing diatoms based on the outlet water. It's not industrial yet, it's not maybe even commercial, but they have been working a lot about this and been able to produce good numbers of diatoms. And these diatoms, they have actually been also then the raw material for silicium in solar cell production. So it's very, very, very sustainable value chain, this. And then what maybe is even more potential is to produce a biofilm. And without going into details, it is possible to use the outlet water from a fish farm to produce a biofilm and then manipulate this a little bit. You can choose different lightings, different harvest rate, etc., and then create more or less the species variation that you want in your biofilm. This is also things in the beginning, but we believe that this has a big potential for treating the outlet water from fish farms. And the target here is, of course, then you are manipulating the production to have certain fatty acids and or certain proteins that you again are using for example, food production, fish food, pet food. It could be used for health products, etc. So here is again from Kari showing that doing some manipulation about light, about harvesting rate, etc. You can manipulate what kind of variation you will have of the colonies of the species growing up in the biofilm. Again, a picture that is showing a little bit about that. And again, we believe that this is the maybe the main solution of biological treatment of the big outlet water from fish farming, because here we have a volume market that is endless according to feed, according to bio oil, according to health, etc. So in some way that is actually the last slide I have before my conclusion, and my conclusion or summary is about that aquaponics. We see a startup of aquaponics now, and the startup is mainly driven by vegetable production, and typically it will be in freshwater systems. But however, and even more potential, we believe that this technology will be further developed to also handling marine systems and also bigger volume markets by producing both algae and biomass in a bigger value chain. And the motivation of this is, of course, for everyone that it's sustainable. We are making everything greener, but of course, to be a little bit economical or selfish or business orientated, this is also a good tool to meet the stricter emissions requirements that will come for all of us in the years coming. So I think that was yeah, my 30 minutes are used. So Anna, I'm done with my presentation. So if you had some questions.
We do have many questions waiting for you to answer. Børge, many thanks for presenting your company, and as you said in a finished sentences, it's definitely inspiring story. So good luck with all your future projects. But now I would like to start with a question from Tobias. I can see that he is part of the Finnish Aquaponics Society. Hello. If the plants and fish species feature similar temperature and pH optima, do you think that one loop systems could be used on a commercial scale? Thank you.
As I said, I believe that the one loop system is a little bit weak to be used in a commercial system. We have been doing it here in our test bed, and it's working, but then it's many opportunities that goes away. For example, our experience from our test beds is that we are able to have a good production on warm water species fish in combination with lettuce. For that, one loop has been working well. But our clear opinion and recommendation is that for industrial big plants, we believe that multi-loop is a more professional and better way, more safety and more optimum.
Thank you, Børge. Can I start with the second question?
Yeah.
Anil Telsburger is asking, hi there, will you have both an aquaculture and hydroponics unit, or will you integrate your plant production in one of these clusters with other aquaculture facilities, biogas, etc.?
I'm not sure if I heard you. Can you please shortly repeat the question, Anna?
Sure. Will you have both an aquaculture and hydroponics unit, or will you integrate your plant production in one of these clusters with other aquaculture facilities, biogas, etc.?
That is, yeah, what we want. It's actually we are starting now with the commercial pilot, and that is a little bit standalone, but the target is that the industrial will be in a cluster like in your question. Of course, we believe and aquaponics has a natural place in a biopark, in a food park, where you have access to biogas, where you have access to other resources and synergies as well. So the answer is that yes, in an industrial setting, we want our systems to be a member of a food park or a biopark.
Thank you. Børge, Anil is asking the second question. Which one of the tested plants is the most promising for production in your opinion?
Well, I guess that will probably be a variation a little bit from what persons you ask, but we see that from the last 3 years now, lettuce is very, very thankful to produce in a system like this. It's don't need too much. It's a good match with the nutrients from the fish. We can see that cucumber and tomato is also good production. There we have to maybe balance a little bit with some minerals. So I'm not sure if I'm able to give a clear answer, but I would say we have good experience with lettuce, we have good experience with cucumber, we have and herbs and microgreens. So it's many good candidates here.
Thank you, Børge. The third question from Anil is thinking of commercial scale. What is the annual production you are targeting?
In the commercial scale, we are targeting I showed the picture of. That is around 40 tons of fish per year and 300 tons of plants per year.
Thank you, Børge. Tobias is asking, do Swedish algae factory, and I'm probably not gonna read this correctly, Smågellax, use the principle of aquaponics, or do they just use the RAS effluential as a growth medium for the diatom?
I have to be honest and say that I don't know all the technical details of what of the Swedish algae factory, but I only know that they are using the synergy of the nutrients in the outlet water from the fish farm. So for me here, it was an example of the synergy between this diatom production and the outlet water from the fish farm. So I'm not able to answer the technical details there. I'm sorry.
It's okay, Børge. The next question is, so two questions from this person. The first one is, what about halophytic plants in a saltwater aquaponic system, Salicornia, for example? You can maybe answer this, and then I will read the second one.
Yeah, I can answer. Yes, and that is done. People have been doing that in more brackish systems of aquaponics, and then I think that is probably a niche production. The question I'm asking then is, what is the potential market for this according to volumes? But it's doable, yes.
Thank you. The second question is, with the ratio you shown, if understood correctly, 10,000 tons of fish and 5 hectares of hydroponics, do you still have some nutrient emissions, dissolved or solid, in the hypothetical wastewater?
Yeah, okay, maybe that was a little bit misleading. The 5 hectares was actually only the fish farm. If you put a greenhouse or plant production to a 5 hectare, it will be much bigger than that. But so as I said earlier, the balance here about plant production and fish production is roughly 1:8. Then you are balancing the nutrients that the fish is producing with what is the requirement for 8 times more plants. And in this situation, we are talking only about the soluble nutrients in the water. The sludge part is coming in addition. And that is, for example, as I showed in the diagram, the sludge will then maybe go to compost or to biogas, etc. So 1:8, that is only the soluble nutrient level, actually.
Thank you. The next question is from Ulf Nermark. Your illustration shows brine back to plants. What plants can take salt water?
Yeah, maybe that is maybe a misleading word. It should probably be concentrate instead of brine, so a nutrient concentrate. So brine is not the correct word actually there, because I understand that is thinking of salt, of traditional salt. So maybe I will change that word to concentrate, nutrient concentrate.
And then what plants can take salt water?
No, there are not many. It was Salicorna was mentioned earlier, but it's not many plants that can handle. So then I think if you want to use this principle, then looking more into algae production and biofilm production that can handle brackish and salt water. I think that will be the solution in the future.
Thank you, Børge. Before we finish with the webinar, I would like to send you the final reminder to send all questions if you have for Børge before we finish the webinar. I will start with the next question, which is from Stamatis. Is it, or in the brackets, or can it become economically viable? Will it be able to compete with traditional production?
Yeah, it's a good question, and because we have seen during the last 10 years, it has been some startups of aquaponics in Europe, and according to my knowledge, not many, or if any, has been a very big success about profits. But I think also these startups has been very small. So if we are now talking about what is the cost to build an aquaponic, and I would say an aquaponic is a fish farm and a greenhouse production or a plant production. The cost it will be the same as to build a hydroponic in an aquaponic than a standalone hydroponic, and it will cost the same to build a fish farm part in an aquaponic as a fish farm alone. And as we know in this business, to build small is very expensive, both in capex and also in opex. So that is probably the main cause why the startups we have seen so far maybe had some trouble to make profits. And my opinion about this is that to be able, at the end of the day, it comes to price, because it will be able to maybe have a small premium, but at the end of the day, it's a fight in the supermarket about who's buying, and then price is important, and then we have to reach the big scale of benefit to be able to compete. So there we are talking about scale.
Perfect. Thank you, Børge. The next question is again from Ulf Nermark. What freshwater fish species will you use in your biggest system?
For us, it will be trout. But you have a lot of candidates there. Yeah, you have many candidates. Sturgeon, Arctic char, trout. Yeah, several.
Perfect. The next question is from Diego Nieto Utata. Hi, interesting presentation. Would you say aquaponics for fish larvae live feed is economically feasible? For example, copepods or artemia combined with algae production?
That's a good question. I never thought about that. I'm not sure if I'm able to answer it in a good way, but according to algae production, there I think yes, maybe algae produced in an aquaponic can be a good resource in a hatchery where you are using green water technique, etc., or algae as feed for rotifers. So I never gone into the details of this, but so I'm not able to answer it very good. But I will look into it. Thanks for the idea.
No worries. And Sarah asked a similar question. Do you think that decoupled marine farm and algae production would be more efficient than using the algae as bioremediation directly in the marine farm, effluent farm?
Yeah, if I understand the question correctly, of course, if you have a fish farm, marine fish farm that is using algae as a part of the protocol, if you can get it directly from your own outlet production, why not? In my eyes, that must be a good logistic, etc. But I never been looking directly into that, so it's a good idea. But if it's, then we're talking again about the scale, the cost of doing it according to the volume, etc. So yeah, it's interesting, but it's hard to say. I guess it will depend on the different situation.
Okay, Bjørn, thank you. Børge, thank you. We still have 2 more questions to answer. Do you have any experience on the taste of vegetables produced? Could it be affected?
Yeah, a very good experience of the taste of vegetables. I'm eating it every day. And we are also selling in the supermarket, in the local supermarket. We are selling every day. So we have very good experience with the feedback about the taste and quality.
That's great. I want to try some of the products if I come to Trondheim.
Yeah, I will bring next time I go to Belgium.
Oh, perfect. Then, wait a second, we received 1 more question. Okay, I'm going to read a question from Bjørn Mirstedt. Why fish will not shrimp in very low salinity be better, or the freshwater prawn macrobrachium?
Yeah, very interesting. And to be honest, that is on our target list for the future. Exactly those species. So we believe that they are very good candidates of this, but still our startup, we think that we have to maybe do it as safe as possible, and then maybe next step can be macrobacterium and the shrimp. So, but yes, definitely it's a good candidates for using these kind of systems.
Perfect. Børge, we received 2 more questions in the meantime. Do you mind if we answer on them?
No, it's okay.
So one of them is, does your company build own aquaponics system, and what is the advantage of your system from others?
the motivation of doing it by ourselves is two things. It's because it's not too many to ask about how to do this. So we have been choosing by learning by doing. So that has been the motivation to start this test facility and also to do the commercial pilot. So that is a motivation. So our company, we have two goals of this. One is to use this to learn, also to build our own, but also use the experience from this to other external projects.
Okay, thank you. And then from Baldassar, don't you think to make economically sustainable, it is necessary a different market organization? For example, traditional producers should pay for pollution remediation.
Yeah, this is very interesting, and and this about market, that is probably maybe one of the most tricky things about establishing this. One thing is that the market should have a premium price for these kind of products. And I think it will be able to have a small premium because of the good story. But that has to be a work in cooperation with the market players. It's nothing a producer alone is able to do. It has to be a cooperation with the chains and stuff to be able to have a small premium. And if I'm trying to look into the glass ball, I think maybe that in the future it will be a requirement, or a little bit opposite of your question, but it will be a requirement that the vegetables and stuff has to be produced in a sustainable way. If not, what we think today is more traditional production, that will not be green enough to enter the market. So I think at the end of the day, probably we will come to a setting like that, that the requirements will be stronger and stronger, and maybe what will be looked as very green production today will maybe be the standard in the future.
Thank you, Børge. And then I will ask you the last question for today, and we are finishing with this webinar. From Michele Zoli, heating or cooling water may be necessary to meet the demands of fish and plants. This could greatly affect energy consumption.
So that's why I say that this belongs into bioparks, because in a bioparks, there you have green energy, solar, wind, pyrolysis, etc. So I totally agree in that statement that it's also important here for the bigger project that the energy is used in this kind of system has to be renewable and green, because it is true, this kind of production, it is quite energy consuming, so it makes sense, that comment.
Thank you, Børge, for joining us today, for presenting amazing presentation. We received a lot of questions, and thank you for answering on each of them really well. Let me also tell you before we finish with the webinar that this webinar was recorded, and it will be published by the end of this week. You will also find the slides of the presentation on the EAS website. So if you are a member of the EAS Society, you can log in on the website and find the slides on the membership EAStalk section. See you on June 6th with Sparos on our next webinar. Thank you very much, Børge, once again, and thank you everyone else for joining us.